Now let's look and see how we can multiply a vector by a scalar. We have this vector here, AB. The vector is 3, 1, and we want to multiply it by this scalar, that is just a number, 2. So what we do is we multiply each of the components. So the x component is 3, when it gets multiplied by 2 it goes to the point 6. And the y component is the value of 1, so when it gets multiplied by 2 it gives us a value of 2. So the final point for this then is going to be the point up here, which is CAB, which really just takes the vector that we have here, and the vector remains in the same direction, but it's twice the length. And the final point is up here. Now let's look at this mathematically. So we can see here that we have the vector AB, which is 3, 1. In our computer science, we write it as an array 3, 1. We want to multiply it by 2, so we're going to have C times AB is 2 times 3, 1, which is going to give the value 6, 2. So the new vector is going to be along 6 and up a value of 2. So let's go ahead and we'll see how we can implement this in our assembly language. On the right we have the calling function, on the left we have the subroutine. So in the calling function we're going to have, first of all, defined a scalar, and for this example we've got the value of 2. And we're going to have the vector which it is multiplying. So again, in this example we'll use the 3, 1. And it means that the length of the vector now is going to be a value of 2. And it's going to save it in this array, and the array length it saves it in, again, has got a value of 2. And we've called it vector multiply underscore scalar, and we've given the ROM address here. So you can see here we're going to push the scalar, and it's in brackets because it's the actual value, which is the value of 2, onto the stack. But then we're going to push array 1 and array 2. So array 1 and array 2, we're going to push the actual addresses where array 1 and array 2 start. And then we're going to push the length. So the length again is in brackets because we're going to push the actual length value here, which is the value of 2. So once we've pushed those onto the stack, we can jump to the subroutine. We head over to the subroutine here. It runs through the subroutine, it works out the actual values, and it saves it in the array 2. And then the program ends. So this is the calling function. Let's have a look at the actual subroutine. Now we start off the subroutine with a bit of housekeeping. We've got to take the values for the registers that we use within the subroutine and save them to memory. So we do that here. We can then pop the values off. So we pop off the return address, we pop off the value into next value into the index register, and then R3, R2 and R0. And you can see the values here described on the right. Now we're now ready to go through the actual loop in the subroutine. So we'll load the value that's pointed to in register R2 into register R1. So we go to this memory location which pulls out the value of 3 here for this array, and we put this into register R1. Now we go through the multiplication. At this point here, register R0 already contains the value of 2, which is the scalar. It was popped off up here. So we can then multiply the value of, in this case, 2 times the value of 3, which will give us a value of 6. And we then store this in register R3, okay, in the memory location pointed to by the contents of register R3. We can then increment R2 and R3, so this is the array 1. So we head off over to the next point here, which will pull out the value of 1, and that we also increment the register R3, which increments the next position where we're going to save the next value. We can then decrement the index register, we do the comparison, and if it's equal, then we finish off the program, so it goes to the return section here. Now if it isn't finished, we've still got another iteration to go, it comes back up here and it goes through the addition again. So it keeps going through this process until the index register has counted down to 0, at which case it jumps to the return and it then goes back and restores all of the values that were in the registers back in to the registers, and then it finishes up with a jump to return address, so it jumps back up here and then it goes to the end. So let's see this actually working on our CPU. I have loaded up the subroutine into the ROM and the calling function into the RAM, so let's run through this and we'll see what is happening. And I've slowed it down a little bit so we can see a little bit better. So again, we're going through the initial setups when we load the original values for the arrays, and the values should come through in the registers at any moment. So we're going to see the value of our 2 times our 3, which gives us the 6, 2 times the 1, which gives us the 2, and now the registers are cleaned back to the original values. So that's it finished. Let's stop this and we will get in and have a look and we'll see what we actually have here. So at position 500, we're going to have the value of 2, which is the scalar value we're multiplying. We're going to have the original array, which is going to be the 3, 1. And we're going to have the length of the array, which is 2. And the final two outputs are going to be our x and y. So this is going to be 6 and 2. So that all works fine. That's us work through another vector manipulation. So let's move on to another one on the next video. Thank you for listening. Goodbye.